In this video, we're going to go over the correct preparation steps that we should take before we start this project. So first thing is, I'm looking at the blueprint here and I'm observing that there are 4 different pieces and they all have their own individual labels. And then over here I have the quantity. So for each assembly, it requires one of the following parts. Now you're making 2 complete screw jacks, and then you will combine your best parts to assemble a screw jack that I will grade. We're going to take a look here. We're going to notice our tolerances on this project. So fractional dimensions, which are going to be the most common, that's plus or minus a 64th of an inch. Angular dimensions, plus or minus half a degree, and decimal dimensions, plus or minus 5 thousandths. Now, we always want to make the best parts that we can, but we also want to take advantage of the tolerances that were provided. We can make parts that are, let's say, plus or minus 10 thousandths relatively easily, but when we try to get to that finer level of accuracy, let's say controlling within a thousandths, then we have to slow down a fair amount. So we're going to really take advantage of this big fractional tolerance. When I open up the print, the part that we see on the left is labeled the base. We're going to start with the base, and one of the main reasons for that is we're going to drill and then tap the hole that goes through it, and that'll give us some threads to check our second part, the telescope screw, with. We can also use overwires and measure our pitch diameter as well. But let's talk about the base for a second, because that's going to be our first part that we're going to start on. Overall length, 1 inch 5/16. There's a shouldered area here that's 5/16 long, and the outside surface requires a medium knurl. There is a groove right here that is labeled as being an 1/8 inch wide, and then the knurled section minus this chamfer right here is 7/8 of an inch long. Now this 1/8 inch wide groove is going to be put on the part using our 1/16 radius tool that you ground last quarter for your thread relief on your turned and then threaded part. There's a note right here on the thread call out, 1 inch 14, and it says we're going to ream and then thread. Now we used to drill, bore, and then tap the hole, or actually single point thread the hole, but I have chosen to start having all my students drill it, ream it, and then tap the hole just to speed along the process. Now a couple dimensions that students really struggle to locate are going to be, first, on this knurled section here, there's no call out from this bottom view, but on the top view here I can see I have an 1.5 inch diameter and I have a 1 5/8 diameter. The 1 5/8 diameter is for the shouldered, the largest section here. That's 1 5/8 of an inch. The knurled is going to be the 1.5 inch. And remember, in order to get an 1.5 inch knurled diameter, we're going to have to cut it under by approximately 15 thousandths of an inch before we knurl it, and then the knurl will actually make that diameter grow, and it will be very close, if not right on 1.5 inches. Now the groove that I was just talking about a second ago, there is no diameter called out there, but if it's a 1/16 radius and I want a full radius that would make us have an 1/8 inch wide groove, then I'm going to need to go in a 1/16 per side, or an 1/8 inch total, in order to get, again, the full 1/8 inch radius. So that's pretty straightforward. And then we should also note that all chamfers are 1/16 by 45 unless otherwise noted.